Shall I say?
Hello, sir. We can hear you.
Okay. Maybe you can turn off video just to be on audio. Will that work? Let's see. Okay, it comes back. Okay, folks. Good afternoon again. Welcome all of you to this webinar by Dr. Dhanesh Kurup from Amrita Vishwavidyapeetham on wireless channel modeling for IoT systems. Dr. Dhanesh is having some technical difficulties. So while you're waiting for him, what I thought I would give you an overview of the research center that is organizing this seminar. The research center by the name Center for Wireless Networks and Applications. So let me give you a brief, introduction to the center, and by the time I think our speaker will be back online, and then we can actually move on to the webinar itself. With that said, let me see how I can talk to you about our center. Okay, let me share my slides. So Amrita Vishwavidyapeetham, as you guys know, it has certain fundamental, aspects in the vision and mission. Things like education for life, meaning we want to inculcate values in addition to technical expertise, and then compassion being the underlying driver for all our research, and finally having a global impact with whatever we do with a tremendous amount of collaboration. And we have several campuses, as you might know: Amrutapuri, Bangalore, Chennai, Coimbatore, Kochi, Mysore, and then new campuses coming up in Delhi and Amravati. Lot of different, schools, various disciplines. Pretty much everything is covered: engineering, medicine, arts and sciences, management. And sustainable development is one of our fundamental, thematic areas. It's a fundamental goal for us because we need to sustain this earth. Otherwise, we will perish. That's the whole idea. So therefore, actually, to kind of validate our emphasis on sustainable development research, recently there was a ranking of world universities by this organization called Times Higher Education. Right? They ranked the universities across the world in terms of the impact made towards the SDG, the Sustainable Development Goals of the United Nations. And Amrita was ranked among the top 100. So that's a great accomplishment. Number one in India and among the top 100 in the world. So that's a great accomplishment. In addition, THE also has ranked us as the number one private university in India year after year for multiple years. We have also been ranked as the fourth university overall, fourth best university in India by the National Institutional Ranking Framework of India. That is also a great accomplishment. And then we are also one of the institutions of eminence that have been, cherry-picked by the government of India. So that gives you an idea of the Vishwavidyapeetham, the university as a whole. And now coming to this research center at the university called the Center for Wireless Networks and Applications, with which Dr. Dhanesh Kurup is very closely associated in terms of joint research, in terms of guiding our students of masters and the PhD programs, etc. And you're going to hear a lot about his own research work subsequently today. Talking about the center, we focus both on research and education, and all our work is interdisciplinary. So the team is interdisciplinary, and the technologies are state of the art, and the solutions have huge social impact. And there is a huge amount of international collaboration as well. So in terms of the academic programs that we have three programs, master's programs. One in wireless networks and applications. So today's topic is very relevant to that program. So, if you are impressed by today's talk and you want to get more into this area, this is the master's program that you want to join. And then we also run another one called biomedical instrumentation, and the third one called geoinformatics and earth observation. Again, talking about the sustainability or the need for sustaining the earth. This is a very important program as well. We even have a school for sustainable development, which is headed by the same person that heads this research center. We also have a PhD program and what we call an integrated PhD, wherein you can join the master's, the MTech program, and seamlessly segue into the PhD program, and thereby you can try to optimize the combined integrated program and finish it faster. So that's the whole idea, right? Very talented, accomplished faculty, interdisciplinary with international academic and and industry experience. Many adjunct professors from across the world, as many as 12 of them, several PhD scholars, a lot of international, you know, interaction possible as part of your MTech program. Dual master's programs are available. Joint PhD guidance is available, right? Student exchange programs. Also, a lot of social, interactions through a program called Live in Labs, where you get to engage with the villages in India. And in terms of our interdisciplinary nature, you can see the different fields in which the faculty have expertise at the left-hand side of the slide. I don't want to name them, but you can see that there are various areas where we have expertise. So through our programs, master's and PhD programs, we cover several domains in technology, state-of-the-art, cutting-edge domains like, machine learning, Internet of Things, IoT, 5G, the latest and greatest mobile technology, latest in Wi-Fi technology as well, big data, because again, today, with all these sensors and IoT networks, there is so much data getting generated. How do we deal with this big data, how to process it, how to make sense out of it? What we call extended reality, right? Virtual reality, augmented reality. So these are various areas. I don't want to go through each and every one of them. Cloud computing, fog computing, right? Geospatial technologies, GIS, blockchain. So various, multimedia. So these are different technology domains that you get expertise at when you join with us. These are some verticals wherein you can develop your career once you have graduated from our center in terms of the expertise you gain in areas like 5G, IoT, machine learning, big data, etc. Right? Industry 4.0, it is like it's the buzzword of the day. Essentially it's about automating the processes and making it more efficient, making it reliant on machine learning, integrating the whole thing through IoT and 5G kind of communication technologies, virtualization in terms of, containerization, network slicing, as they call it in 5G. So a lot of these technologies, and that in turn leads to a lot of job opportunities. It just gives you an idea of what is out there for you to grab, right? We have been running as a center for more than 10 years now, about 12 years. And in terms of the placement and internship record, when we talk about our master's programs, it's a 2-year program, and the second year of the program can be utilized to do an internship at a company, at an industry. And then typically, when the company is impressed with the performance of the candidate, the internship turns into a placement, a job, right? So the green ones you see are the product companies which work on specific products in this domain. We also have recruitments with IT companies, which are more broad-based, and then a lot of startups. The blue ones that you see in the second column, most of it, those are startup companies, and some educational institutions that you see in the third column as well. So there's like a wide spectrum of different placement opportunities that are available for the students when they graduate. In terms of the international collaboration, you can see that universities and institutions like the VU, the Free University, the Amsterdam, the TU Munich in Germany, Zurich, Switzerland, ETH, right? Trento in Italy, University of New Mexico in the US, Colorado State. So we have collaborations wherein you get to do things like dual degree. In the same 2 years of education, you get to earn 2 degrees if you are qualified. One from Amrita and one from one of these, whether it is VU, whether it is UNM, you can choose. And also there are opportunities for student exchanges and visits and that kind of stuff. In terms of the faculty, I was talking about Dr. Manisha Ramesh being the director, who also heads the School for Sustainable Development. So you also get to do your PhD in Sustainable Development if you choose to after you finish your master's. We have close to more than 100, international students doing their PhD with the School for Center for Sustainable Development. She has the distinction of having been ranked among the top 2% of scientists in the world by a recent study by the Stanford University. That's a great feather in her cap, and so many others. I don't want to go into details. Just to give you a taste, right? Dr. Menon, with experience in the industry in India, R&D, DRDO, a lot of experience in ultrasound, underwater communication, things like that. Professor Balaji, Professor Setu Rao, that is myself. We both were in the US for a couple of decades in the industry before joining Amrita as faculty. Dr. Odhavan was the Director General of GSI, Geological Society, Geological Survey of India, and so that he brings a wealth of experience to the table in terms of geospatial technologies and all that. Dr. Ravishankar was QSAT, a lot of experience again. And some of our, next generation faculty, so to say, again, very accomplished. Some of them have actually earned their PhD from Amrita. They've been with us, they've grown with us, and they have so much to show in terms of the publications and patents, as you can see there. Some of them even have done their PhDs abroad, like Dr. Alka Singh, who did her PhD at Munich, TU Munich, and then worked as a postdoc at NASA for a couple of, for a few years. Dr. Martin also has a PhD from Germany, right? Very accomplished. And then in terms of adjunct faculty, we have again, a very impressive list. I don't want to run through that. Dr. Seshia is a 5G expert. Dr. Dilip with Geo, a lot of industry experience coming in. And many of them actually offer courses. Qualcomm, we have several people from Qualcomm offering courses, guiding people in their research and so on. In terms of the research at the center itself, we kind of divided into 4 buckets, so to say. Extreme environments, IoT applications for extreme environments, wherein we talk about flood monitoring, landslide monitoring, right? Communication system for fishermen. That is one area. Second area is wearable medical systems, right? Especially in today's scenario of COVID, our research has become very relevant, and we have a hospital, as you might know, at Kochi, which is world class. So we work very closely with the researchers and the doctors there to work on various areas to develop wearable technologies for monitoring the vitals, for scanning thermograms, for potential cancer detection and so on. Again, I don't want to go into the details. A lot of work in smart infrastructure as well, in terms of smart grids, smart homes, smart offices, even water-based research. A lot of water-wise communities, IoT-based monitoring of water quality, etc. And finally, there is research in the area of what we call extended reality, right? Again, in today's environment, when things have to be remote, because classrooms have become remote. So how do we make the experience more immersive? How do we make the remote classroom more interesting? So that kind of research. How to use things like augmented reality for some of our heritage structures to reconstruct digitally and so on. So some of the world's first in terms of landslide monitoring, and all our projects have deployments. So that is the beauty of our work. Everything has a practical value, practical significance, and benefits the society. So you can see the impact of this landslide monitoring project. For example, we have one deployment in Munnar in Kerala and one in Sikkim in the Himalayas. And then this is the ocean net for providing affordable internet to fishermen. Again, we have a deployment right along the Kerala coast here. A lot of state-of-the-art laboratories, a lot of apps also, like the flood monitoring app played a vital role during the Kerala floods in 2018 and 2019. We call it Amrita Kripa. And this, in terms of the wearables for monitoring ECG and other vitals, the project was launched by our Honorable Prime Minister, Sri Narendra Modi, a few years back from our campus right here. I talked about the international collaboration. So you can see several joint research centers that we have set up, several projects we have done with international collaboration, and you can also see our partners out there. And this is a growing list, right? In terms of the accomplishments, in terms of number of journal papers, number of graduates we have produced, and so on, number of patents, and quite a few from the students, as you can see. So 10 out of 20 patents that we hold are based on the work done by our students. This is the final slide, I think. So this is the project, very, very unique project at Amrita, not only this center, across Amrita, wherein there's a lot of international participation. Universities from across the globe send their students to work with us, with the students and faculty of Amrita, to go to the villages. We have adopted more than 100 villages across India in various states. So we go to those villages and we try to look at their specific needs in these different areas: agriculture, education, energy, water, health, waste management. So these are different verticals we look into and identify their unique needs and try to provide custom solutions by getting the students to work on them. So they can even produce their master's theses or even PhD theses based on this work they do. That's what happens. It's not about potential; it's reality. And I think that kind of sums up my presentation. I think Dr. Ganesh is back, so I will hand it to him without much ado, and we can get on with the topic of today. So let me stop sharing my screen. And before I hand it off to Dr. Ganesh, let me give a brief intro to Dr. Ganesh. So let me give you overview of the accomplishments of Dr. Ganesh G. Kurup. As you know, he is currently a professor with Amrita in the Department of Electronics and Communication Engineering in the Bengaluru campus. He leads the RF and Wireless Systems Research Lab at the campus. He has worked both in academics and in industry, and he's pioneered some work in antenna arrays, unequally spaced antenna arrays, active reflect antenna arrays, etc., for spatial power combining. And these are like pioneer work, right? First of its kind. And he has a patent in the area of ultra wideband based passive chipless RFID technology. His expertise includes all aspects of active and passive RF circuits, computational electromagnetics, signal processing, behavioral modeling, and simulation of wireless systems. So he was a scientist engineer with the Satellite Center at ISRO, Bangalore, right? He's also worked as a guest researcher at the University of Rennes, France. I don't know that I got the pronunciation right, maybe Rennes, France for 3 years. And he was also at WaveLogix AB Sweden for 8 years, right? He has a PhD from Uppsala University of Sweden and the University of Rennes, France. He also has a licentiate degree in signal processing from Uppsala. He has his MTech in microwave and radar from IIT Roorkee. And prior to that, his BTech in electronics and communication engineering from Calicut University, Kerala. With that, I would like to hand over the floor to Dr. Ganesh Kurup. Dr. Ganesh.
Yes, thank you. Thank you, Professor Sethu sir, for the generous introduction. I hope everybody can hear me.
Yes.
Yes, thank you. And you see, I had a very bad internet experience just before the start of this meeting at home. I have a Tata Sky connection and Tata internet connection, and somehow I think some maintenance work is going on without notice, because Bangalore is a developing, India is a developing nation, so things happen without notice. So luckily the institute is Amrita University Bangalore campus is pretty close to my house, so I have to drive. I didn't hit anybody. I reached on time, I think. So thank God I am at my office comfortable now. So let me share my screen. Just a minute. Desktop share. Can you see my screen?
Yes.
Yes. So I will put it in slideshow. So, sir, is it visible? I hope.
Yes.
Yes.
It is in slideshow. Yes.
Yes. Thank you. Thank you, sir. And very happy to present a very relevant topic of today, which is IoT systems. And related to IoT systems, I'm going to present to you this wireless channel modeling. In fact, that is one of the most challenging part in IoT deployment. So one must understand that we have, very cheap IoT devices today we can buy. And sometimes when you configure everything, when you do all the hardware related things, then suddenly you realize that, hey, I don't have a link. So this is often the problem. So the reason why the link is not good is because the wireless channel is not functional 100%. That's the reason why the link is not good. So how we deal with this issue, how we can model wireless channel. So these are the topics of my presentation. Now, what is IoT? I thought just jumping into wireless channel modeling is not a good idea. So briefly, I will go through what is IoT. Okay. So it is going to be a $1 trillion market by 2030. One must understand 1 trillion is not a small amount, right? And the youngsters like you, most of you are youngsters, I think, who are listening to this, you can do, many of you will have a lot of ambition to start your own company and all that. So this is a very, very good area to work on because a lot of money is involved. Even today, you see, so just before jumping into a formal definition of Internet of Things, so I just want to introduce, you might have experienced Internet of Things in your life, at least if you have passed through a toll gate today with a fast tag on your car. So you know what is happening. So the thing here is your car, and you have a tag on your car, and earlier days, like 5 years back, what was going on in toll gates, in highways, national highways, and so on. You have to stop there. You have to open the window. Somebody will come, and then you have to pay the money, and you have to, they will allow you to pass. But today, what is going on? At least you don't have to slow up. You have to very slow down your car, and then suddenly your car will be red, and suddenly the information about your car will be searched in the internet for how much balance you have in the tag. So here thing is the car, and the car is automatically connected to the internet, right? So if you have experienced that, you are a user of IoT already. So for example, Saturday, I drove all the way from Kerala to Bangalore. I passed through several toll gates. Without my knowledge, my wallet kept on reducing, and the passage was very smooth in all the toll gates, and I was so amazed by this technology. So you see, and in future, many more things are going to come of similar profile. Now today it is just the car. You see what is happening in the car application, toll gate application. In the cloud, your account is linked. So the cloud is monitoring how much balance you have. And all the internet protocols are in action to determine how much balance you have. And the thing which is the car will be read by the reader in the toll gate, and automatically the money will be deducted. So wonderful. So now I am going to formal definition of Internet of Things. So everything has a formal definition. So what is IoT? So IoT is a system of computing device, mechanical and digital machines. Okay, is a system means it is a thing. It is computing device, mechanical objects, digital machines, objects, animals, people. They are provided with unique identifiers, unique ID, and they will have the ability to transfer some data over a network without requiring human to human or human to computer interaction. That is why it is a very, very interesting technology, because whenever human enter into a technology's domain or a technology that connected dots, human enter, everything gets slowed down, isn't it? So if everything is automatic, the services and everything will be very fast. So that is the advantage which Internet of Things offer. Now, there are a lot of IoT applications growing every day on a daily basis, but I would like to outline top 10 IoT applications. I think that will, a really nice way to start the IoT. So what are the top 10 applications? So the first is smart home, then there is wearables, then there is smart city, smart grids, industrial internet, connected cars, connected health, smart retail, smart supply chain, and smart farming. These are all going to be, some of them are already there. You can experience IoT. You can have an IoT experience in some of these domains, and some of them active research is going on in many companies. So, for example, smart city initiative is an initiative from Government of India to make our cities smart. Today, our cities are very messy, overcrowded, traffic, services are not good because our cities are not smart. So they are not able to deal with such a huge population. And India is going to gain tremendously by IoT, making the city smart through IoT. Then there are smart grids. Today, a lot of wastage of electricity is there, as you know. So sometimes there will be power outages and so on. By deploying IoT into smart grid, we are going to gain tremendously in terms of services, cost, savings, and so on. So I'll go through this one by one. The first IoT application which I would like to discuss is, to you, is the smart home application. Smart home means, it is not just the smart city. You can make your home also smart. See, what do you mean by smart home? It enables us to control domestic appliances by electronically controlled internet connected system through a central hub and remote controlled by a mobile app. If you give me a second, I'll just try to configure my pen. Just a minute. Yes. So I hope you can see my pen or the cursor. So it enables us to control domestic appliances by electronically controlled internet connected system through a central hub and remote controlled by a mobile app. Use cases: controlling complex heating and lighting systems, controlling home appliances such as refrigerators, setting alarms and home security controls. I would like to tell you another application which I was thinking. Today people are not able to go out of their homes because they have plants, they have animals and so on. So imagine a situation where you can monitor and give food to your dog, water the plants from a remote distance, maybe 100 kilometers far, by means of robots and so on. So then once you have done it, I think you will have a smart home where you don't have to physically be there at home, and yet you can have all your home. Today, when, see, for example, if you have pot plants like roses and so on, you are tied to your home because once you come back after a vacation, it's all dried up. You're not able to water, because if you don't water your plants, it will get dried up and there is no. So such kinds of insecurity are there in people when they move out. If you have pet, a similar problem. So I see a lot of scope in making home smart. Okay. So another simple things are, when something milk is finished, you get a message in your phone. So these are kind of already done things. If you can control your heating and lighting, and depending upon the time of the day, you can set so many things like lighting and so on. So these are all already done things, and students have done very good projects also. So IoT, in short, IoT has a lot of scope in making homes smart. Now, next is smart wearables. What do you mean by smart wearables? You can have a host of gadgets on your body, which can give you indication of your health and so on. It starts from smart bracelets, smart glasses, smart watch, smart shirt, key tracker, smart shoes, smart pants, smart belt. So these are, what these devices contain. They will have special sensors inbuilt, and many of them are patented, and the manufacturer have already patented. And what will happen when these devices are connected to the internet? You can gather a lot of information on a 24/7 basis about your health, about your activity, how much exercise you have done a week, and so on. And this data, you can access by visiting a particular site, and you can monitor what your activities are. And if something is wrong, you can consult your doctor, or if your exercise is not enough for the weak. You can go to gym and so on and so on, and that keeps the population very healthy, isn't it? In Corona times, health is the biggest issue. So such kind of devices, when they are connected to internet, will offer a lot of scope as far as your health is concerned. And such networks, if you have multiple objects connected like this, and then you say that it's a body area network, it's a technology enabled. So whenever you hear W-BAN, it means wireless body area networks. And IoT is the driver for making wireless body area network feasible. So smart city, I have already discussed, so in a city, there will be a lot of things going on. There are buildings, they are tapping solar energy for the home, and it will be giving to grid, and logistics, parcels have come to a particular home. So which home, whether it is delivered, how much energy is consumed by each home, what can we have agriculture inside the city now? A lot of it is becoming a very popular thing in cities, agriculture. You might be wondering why. For example, Singapore is the leader in city-based agriculture. In their rooftop, they are growing all sort of vegetables. So if you can produce your own vegetables, your own food items in city, through smart city and IoT, it's a great job. So I hope India will emulate Singapore to make cities smart. So today, as you see, there are a lot of chaos in cities, big cities, especially like Mumbai, Bangalore, Chennai, and so on. You can see that it's so chaotic. So I am sure that in future, our cities will be much smarter and much cleaner, clean air, and through this smart city based on IoT. So there is smart grid. So smart grid is a highly flexible, secured, and green power system by using integrated IoT, two-way communication, and advanced control technology. Smart grid means, individual house in future is going to generate power. That's a very interesting fact. Individual home, because today we can install solar panels at home, and sometimes you generate excess power. You will be able to generate excess power. Suppose you install a lot of panels at home, you will generate power more than your requirement, and you can sell this power and put this power back into the grid, and you can earn money. So people are thinking about such business models where cities will generate their own power rather than hydroelectric and coal and all that. So that coal is a very dirty technology. It is emitting a lot of greenhouse gases into the air, and it is due to that our health is compromised. And hydroelectric, once you build hydroelectric dams, for example, it submerges a lot of forest. We already know that a lot of pristine forest is submerged in hydroelectric dams. So that's not a good idea. So if we can generate, individual homes can generate power through solar and put it back into the grid, and everything connected and monitored properly by a central hub, for example, a cloud. So what a beautiful way of making everything cleaner. So IoT will be the enabler for smart grid in future. Now you can. There is another interesting technology which is happening, which is the industrial IoT. Industrial IoT is intended to work in harsh environments. A factory floor, car production areas, assembling unit, cloth factories, and so on. So once you have IoT connected, so where are these IoTs? What are the things and what is connected? There will be tools, machineries, processing, analytics, people, so many things. If you have visited a factory floor, it is like worse than a marketplace. You have all sort of things lying around a large area. You might have seen pictures of car assembly units and so on. So it's a very messy area. There will be a lot of tools lying around and so on. So if you can make things smart, the processes will become smarter and productivity will be very high at a very small expense. So that is the idea behind IIoT. It is IIoT. So it is IoT, but it is applied to industry. Now IoT in transportation. See, if every car is a thing and every car is connected to internet, so you can imagine, each car or each vehicle can communicate between each other without your knowledge. Okay. For example, in highways and so on, you can make this system work very easily, because you see roads are very straight, you will have good links, and what is happening, say 2 hours ahead of time, can be known to a driver who is driving very slow and so on, and he can take decisions. For example, 200 kilometer ahead, there is a traffic jam, there is some maintenance going on, there is an overhead, there is a this bridge being built. So today you'll see we will not be able to get this information. So if all the cars are connected with each other, this information can be passed to a car which is so behind, and he can go to a restaurant and spend some time before he embark on his journey. So that is a good thing. So IoT in transportation will enable, the driving very smooth. And in cities especially, you might have noticed there will be sudden traffic jam. No matter it is New York or Mumbai, even in New York, these problems are there. So if we can solve this transportation problems by means of IoT, that will be a very good idea, especially a country like India with such a, densely populated cities. We are going to gain a lot by IoT. And connected health. What do you mean by connected health? In the connected health, there will be like the wearables, which I have told earlier. You will be wearing all this, and how you use these wearables for different applications. And that is the enabler for connected health. Okay, for example, your health parameters can be passed on through internet to a remote doctor. He can be an expert in another country. There are a lot of doctors, very good doctors, maybe spread over. That particular doctor in a particular specialization may not be available in your city or your town. So still, all the parameters can be passed through telemedicine. And the doctor can diagnose the disease, or he give you proper treatment and so on. So digital health, these are all interrelated. Telehealth. So IoT will be a very big factor in future for connected health. Then there is smart retail. As soon as you enter a shopping mall, all the information about a particular item you are searching for will be available, which shop it is available. You can compare prices, and without spending a lot of time, you can give a message to the person who is inside, and he can take the correct cloth for you and be ready there, and you can wear it, and so you can save a lot of time. So, and the information is the key. Lot of information will be available in your, for example, in your personal digital assistant, which can be a mobile phone, for instance, and so on. So smart retail is going to be a very interesting application. This is the 8th, top 10 IoT application. And IoT-based smart supply chain. You see, we are eating oranges sitting in Bangalore because that orange is coming from somewhere. Okay, well, Bangalore is not producing any orange. Okay, so that means things are constantly moving. Whatever we want, rice, vegetables, all these are coming from so far off distances. So suppose somebody, a person, for example, Reliance retail chain, they order some items. Okay, it is shipped from somewhere. They can constantly monitor the items which are coming to their warehouse. Okay, not only that, they can also check what is the temperature inside the vehicle, for assurity of, for example, if it is say the food item need to be preserved in a with say -10 degrees. So today we don't know whether somebody, they are protecting the food properly. If it's not refrigerated properly, our health will be compromised. So you can constantly monitor the temperature of the items inside moving vehicles, inside warehouses, and so on, before it reaches the city. And you can imagine the benefits which it brings. So your health will be very good. and also unnecessary delays are not there, and so on and so on. Everything is automatic, and there is very little human interference in such IoT-based smart supply chain. Today, people are building these kind of supply chains very smartly. As and when different goods pass through different warehouses, immediately it will be registered, and you can monitor this, and so on and so on. So IoT is going to play a big role in smart supply chain. And this is one of my favorite applications, because IoT-based agriculture. I've been thinking about agriculture. We can gain a lot by making agriculture smarter, right? So today, we are misusing our resources for agriculture. Either we are not using resources properly, or we are using it too much and wasting a lot of resources. So how we can make smart agriculture possible? You can have several sensors installed in the agricultural field. That these sensors will give you valuable data about nutrition, water quality, content, and so on to you. And you can take smart decisions, depending upon the time of the year, and so on and so on. If it's a rainy season, you need not water a particular the crop as much as you do it in summer. So such kind of smart decisions you can take, and everything can be automated. Sprinklers can be made to automatically work. Okay, delivery of you can take action against weeds, pests, and so on very smartly by means of drone and so on. And the drone will be giving data to the internet, and you can monitor it, and you can the nutrition of the soil, and so on and so on. So agriculture, once it becomes smarter, the yield will be better, the quality of food will be better, and so on. So we will gain, as a humanity, we will gain a lot by deploying IoT into agriculture. Now, after we have gone through some top 10 applications of IoT. Now let us look into the engineering part of IoT. What is IoT? So we are all engineers, so we would like to know how the architecture of IoT is. Yeah, there is a 3-layer model for IoT. One can imagine 3 layers. Okay, application layer. That application layer means these are some programs, GUI programs or otherwise, which are residing in cloud servers. This is called the application layer. Okay, there will be industries working in future. They just write application layer, and their business model is making applications of IoT. So probably our Infosys is going to be smart, and they invest a lot of money into making an IoT team for making applications, right? So then there will be the network layer. Network layer means it will be connected to the application layer, and network layer means what? It's routers and gateways. Okay, gateway. What do you mean by a gateway? Gateway is the place where the data will be going to another layer called perception layer. So what it means, for example, your phone can be, the mobile phone can be imagined as a perception layer, and the router can be assumed as the network layer. So this is what is it. So in the perception layer, which is not like phone, right? The applications which are intended with IoTs are not the kind of applications which you deal with phone. So what are the applications here? We will have sensors and actuators. Sensor, the moisture measurement units, actuators, a sprinkler unit. Actuator means you will get a command and you will be operating a mechanical device. That's called an actuator. Sensor means something which sense, for example, moisture. So if you have sensor, a moisture sensor, and a sprinkler unit, you can automatically operate the sprinkler unit based on the data of moisture. So that makes this perception layer. So you can imagine there can be so many items. It's not just agriculture we are thinking of. Like we have seen all the application, smart grids, smart wearable body area networks, and so on, so on. So sensors and the actual sensors and actuators will be different. But what is important to understand from this slide is this perception layer and network layer talk to each other, And you don't want the sensor and actuators connected to the network layer by means of cables and so on, optical fiber and so on. This is where the wireless come into the picture. So the wireless IoT means the interconnection between network layer and perception layer. That perception layer, which is composed of sensors and actuators, network layer, which contain routers and gateways, they are connected to each other by means of wireless. So there is no cable. So which makes the application scope of IoT very interesting, because now suddenly when it becomes wireless, what will happen? The sensors and actuators can move around. It need not be stationary at one place. So that makes, robots, you can operate robots through IoT. You can have smart sensors in agriculture and so on, and you can deploy it. It becomes suddenly a plug and play technology. So the advantages it offers when the connection between network layer and perception layer become wireless are increased mobility. We can deploy the technology very fast, deploy IoT very fast. It has increased coverage area and scalability. You can make it this IoT more. You can add more and more IoT devices or remove few IoT devices. Configure them very fast. So imagine the situation when everything was connected by wire. So it would have been a miserable, experience to deploy IoT in one particular application. So wireless offer a lot of advantage. So now you know what is a wireless IoT. Now, this slide contains a case study in agriculture, which is my favorite application as far as IoT is concerned. You can see that in the left side picture, you have a remote user, you have a cell phone, you have a database server, you have a gateway node. See, so from here, the network layer starts, the gateway node. You can see that gateway node here. So that is where IoT will be coming, IoT device will be coming, and the sensors and various actuators will be distributed over the field, and they will be connected to the gateway node. So suddenly gateway node can monitor what is going on in the field through wireless technology. And you can see the condition of the field hundreds of kilometers far, because internet is everywhere. So you just have to log into a particular server and you can monitor your field from a remote distance. So what an interesting advantage, possibilities it opens up. Now you see, and similarly, you can operate remote control drones, and the IoT will be the gateway will be in the drone, and the sensors can be there, and cameras can be inbuilt. There may not be any extra sensors on the field. For example, cameras will be installed in the drone platform itself, and by enabling the drone as a thing for IoT, you can imagine that so many things can be monitored from a remote distance. So very interesting applications are opening up in agriculture. Now, we are going into technicalities of wireless IoT connections. What are the possible wireless IoT connections? There are many types of wireless IoT connections. Just look at my time. So based on connected entities, device to device means devices will directly talk to each other. That is one type of connection. Then there is device to gateway, where the network layer is located. Network layer starts. So device will be connected to gateway. There will be a wireless link there. There can be wireless link between device and device. And then there can be wireless link between gateway and data systems also. For example, in the previous slide, you have the gateway node. Gateway node itself can be a wireless because it is an isolated. There is no cable between IoT, this internet and so on. So gateway itself will become. So such kind of connections are also important to make IoT enabled in different applications. So gateway to data systems will be wireless. So between data systems. So that sometimes between data systems you need to exchange information. So such entities will also be wireless. So you can imagine, so a lot of connections will be wireless. So this makes little bit uncertain how the technology will be in future, because when things are wireless, there are a lot of issues also along with it. You yourself will experience when you are far from cell phone tower, the link will not be good. Your browsing experience will be bad. You will not be able to connect to our relatives. So that is the problems, right? So wireless, although it brings a lot of benefits, there can also be a lot of issues. Since there are a lot of wireless connections between device and device, device and gateway, gateway to data, and so on, because there is a lot of wireless connections, the technology, how successful the technology will be little uncertain. For example, I have an experience when I was driving all the way from Kerala to Bangalore. At certain places, one place especially, that reader was not very good to read my tag. So what happened? This person came out and bought a handheld scanner and read my details about my car, and he went away. We had to halt a little bit. So the reason why it did not work there, because the wireless connection was not good. So now you know how important the wireless is for IoT technology to be successful. So what are the types of IoT connections? So we can, earlier slides, based on connected entities, we can, classify wireless connections. Now, wireless IoT applications can be divided based on the coverage area. For example, it can start from few micrometers to hundreds of kilometers. Okay. The things, when they are talking to each other through internet protocols or sensors or actuators which are talking to a network layer, few micrometers apart, they will be classified as nano networks. Okay. And now you know what is near field communication. Most of the phones are enabled with near field communication. So they will work up to 4 centimeters. Now there are body area network. The complete network is distributed over your body. And then there's personal area network. Personal area network means it is a couple of rooms in size. This division is based on the size of the network. Okay, size of the wireless network. PAN means personal area network. It can, the span of the network, wireless network, is roughly a couple of rooms. Then there is LAN. It can cover an area of one building and so on. CAN, campus corporate area network, for example, an entire university, enterprise, and so on. Such kind of networks are called CAN. MAN, metropolitan area network, where the network, wireless network is within a metropolitan area, like a city, for example, and wide area networks. These are hundreds of kilometers apart. Now, you know why we are very much concerned about these classification, because suppose you want to make an IoT WAN network, wide area network. These devices has to talk to another device hundreds or tens of kilometers at least, right? And suppose these devices are wireless, you can imagine when more the distance you want to talk to, more power you need to spend, isn't it? More power you need to spend. And when there is more distance, another problem is the reliability of communication, wireless communication will be in question, right? In wide area networks. So in order to make IoT successful, a lot of work needs to be done in wide area networks, MAN and CAN and so on. And it is already proved, we can easily prove wireless IoT technology in up to LAN very easily. But MAN, WAN, or CAN and all are ongoing research areas. Okay. For example, if you want to deploy an IoT network in a farm which is say 50 very wide and hazardous and so on, there are a lot of issues there. And city, within the city, how these IoTs are distributed. For example, smart city. Okay, it automatically becomes a MAN network, metropolitan area network. So in order to make this IoT smart city work, metropolitan area network, wireless networks has to be reliable and so on. So that makes these areas still a fluid area. We are successful in some place, for example, toll gate, but we are not successful in certain areas. So as and when, in few years time, the research will be done properly by big companies universities and so on, and we will solve all the technology hurdles. And one day, things will become as easy as NFC, a man and van based IoT. Now, to complete the type of wireless IoTs, this kind of configuration. For example, there will be different nodes distributed in a IoT networks. The node can talk to each other through ring, star. Star means, there will be an intermediary node through which only we can talk to other nodes. Fully connected means each and every node will be connected with each other. Then there will be tree structure, then the line structure. The line structure, when we were talking about the smart transportation, there will be car lined, and each and every car will be connected, and you see the communication link will be established to the car, the front car and the last car through intermediary car like a line. So this is the line network, then there is bus network, mesh network, and so on. So this is just for an academic slide. There's nothing new or interesting in this, but for the sake of completion, I have presented it. Now, requirement of IoT networks. The capacity to connect large number of heterogeneous elements with high reliability, real-time data transmissions with minimum delays. Okay, that's one of major requirement. The latency, this delay is related to latency of this network. Ability to protect, security is very important. So a lot of research is being done in making IoT networks secure. Ability to configure applications very easily, monitoring and traffic management at the device level, cost effectiveness for a large number of connected objects, power consumption. We are very much concerned about power consumption. You see, we are saving a lot of power through smart grid, but if the IoT devices itself consume a lot of power, then it's not an interesting technology. So we have to make sure that this wireless network consumes as little power as possible without requirement of charging, recharging, changing batteries, which are all not convenient stuff as far as IoTs are concerned. And of course, security, which is again outlined. So these are the requirements of IoT networks. Now, are there any IoT wireless standards? Yes, your cellular network can be made because it already has an internet. You see, you're through 2G, 3G, 4G, 5G, and 6G research is, by the way, already started. So cellular network is already, is a reliable IoT internet network. So you can talk to a cell phone tower, your things can talk to cell phone network. And if you can use this existing cellular network and things can get connected to the cellular network like cars, yourself, sensors and actuators get connected. You can use this infrastructure and then you can say it is a cellular based IoT wireless network. Wi-Fi, similarly, Wi-Fi you can use, home Wi-Fi you can use for IoT network. The gateway can be a home network. You can use Bluetooth, Zigbee, MQTT. This MQTT, AMQP, BDS, and LoRa, these are all relatively new stuff. Okay. The earlier ones, the cellular, Wi-Fi, Bluetooth, Zigbee, etc., are not designed to make large-scale IoT deployments because these protocols are designed for reliability and so on. So as a result, power consumption will be very large, and you cannot afford to have large power consumptions in the protocols. So special protocols are being developed: MQTT, AMQP, DDS. Out of that, LoRa is the super standard. LoRa WAN. It has a maximum range of 100 meters. I'll be comparing it later. And, it has a large scope. It is actually a low data rate, large range communication network, which is really, really interesting for sensors, actuator, IIoT, and so on. So I'll come to that in the next coming slide, I think. So before going into that, comparing two different many standards, I would like to go through what do you mean by a physical layer of an IoT. Electronics engineering or electronics communication engineering basically is, they study this physical layer of wireless IoT, knowingly or unknowingly, okay? Various subjects are there which you deal with. Basically, they deal with the physical layer of IoT. What is physical layer of IoT means? A wireless IoT means you have the information. The information can be an internet protocol or something. So source encoding. Source encoding means you make the, you add more bits into the source, or sorry, it's the vice versa. Source encoding means you make the, reduce the number of, you encode it efficiently such that you are little overhead in the network, wireless network. Source encoding. Then encryption, channel encoding, modulation. You know what is modulation? QPSK, BPSK, AM, FM, these are called modulation. Multiplexing. And then you connect to something. You see that? This is the RF part, high frequency part. The connection is not made yet. So I just want to show you separately. So this contains RF components, including antenna. Okay, these are high frequency components. And they connect to a receiver. You see, the receiver. Receiver contains LNA, LO, so on. So I'm not going deeper into this. Now, what is really happening is this, in the wireless channel, what is happening is these ones and zeros will be converted into waves. That is what is happening in the world. So when you measure the physical, what is going through this wireless channel, you will not be able to measure bits, large voltage and small voltages, which are familiar in digital electronics. What you will measure is a carrier wave. For example, if it's a BPSK communication system, the one will, whenever there is a 1, you will see a 0-degree carrier, and whenever there is a 0, you will see a 180-degree phase carrier. So that is what is happening. The carrier will shift according to the bits. Now, I have one question for you to think about. The thinner the bits, okay, when you make the bits thinner, for example, your ones and zeros are thinner, okay, what will really happen? You can send large data over the channel, wireless channel, naturally. When the bits are very thin, the ones and the occupancy in time of this bit string will be smaller. So you will take a very little time to send a large amount of bits. Okay. Conversely, when your bits are very thicker, or when ones and zeros are defined over a large duration, what will happen? You will not be able to send data as fast as you would like to. But there is a price to pay when you make bits thinner. When you make the bits thinner, what will happen is the bits are going to occupy more bandwidth. So when you want to have large data rate, naturally, you would like to have large bandwidth in the wireless channel. And bandwidth is a scarce resource. Government would not like to give you bandwidth very cheap. If you want to, so for example, cell phone companies have to pay a lot of money for large bandwidth, right? Their bandwidth which they use. So there will be tenders and so on and so on. So you have to be careful. So, these are things which you have to be remembering in the physical layer of wireless IoT, whether you should send the data with large bandwidth or small bandwidth. Okay, so you have to make sure that you use the appropriate technology. For example, LoRaWAN, which I have told earlier in the other slide, it's actually a low data rate technology, but it has a larger range and reliable. Compared to, on the other hand, Bluetooth, it's a high data rate technology, okay, but it has a shorter range. So, and you have to take wise decision whether you should go for a Bluetooth or a LoRa. A reliable technology is always better, but you need not have large bandwidth or large data rate when you deploy IoT in a farm. So you can choose a technology which is gives you smaller bandwidth and larger range rather. So these are decisions you need to take. So the knowledge which you need to be good in these kind of things is so electronics engineering is really important in to fundamentals of electronics. So is really important to understand really what is happening and so on, signal processing and so on. So physical layer of IoT deals with this kind of issues. Now, of course, just before the source encoding, everything is computer science, basically computer science, networking, network layer, application layer, and so on. But just before the wireless connection, these things which are happening here are called the physical layer, and the technology here is various things like RF, part, modulation, multiplexing, they are all belonging to physical layer. So there is a clear demarcation between different technologies involved in wireless IoT. Okay, this is what I was trying to tell you. I would like to compare two different IoT standards. Bluetooth. Bluetooth is a technology which is working in 2.64 gigahertz. Bluetooth low energy, the modulation is GFSK. It has a range of less than 100 meters with various possible data rate and maximum throughput of 1.37 Mbps. You can imagine that. 1.37 Mbps means you can transfer picture very nicely from one point to the other and so on through wireless. But it has a shorter range. LoRa, very successful technology. The company is making a lot. Companies which are involved in LoRa standards are making a lot of money. And what is LoRa? They uses a frequency, UHF frequencies, 868, 915 in North America, 868 in Europe, and 433 in Asia. Modulation is spectrum modulation. You see, such a beautiful technology. The receiver sensitivity is minus 147.88. So it can decode signals at such small power levels also. Can go up to range of 15 kilometers, but recently there are reports of making this 100 kilometers and so on with much more efficient coding and so on. So maximum throughput reported is 6 kbps. So you cannot send data as fast as in Bluetooth using LoRa technology. So various standards has plus and minuses, and you have to make a decision according to your requirement. Now, signal degradations in physical layer. What are the signal degradations in physical layer? Because you are using a wireless technology, the signal degradations in the physical layer will play an important role in the performance of wireless IoT. Nonlinear amplifiers will cause intermodulation. Intermodulation in turns will cause interference in the adjacent channels. Noise, antennas, gain mismatch, mutual coupling, and not because of lack of time, I'm rushing through this. There will be bandwidth mismatch of, and finally comes to these wireless channel imperfections. This is the topic of discussion, and I'll go through this very fast. So what are the wireless channel imperfections? And as you know, wireless channel describe the electromagnetic wave received by receiving input from the transmitting end. The wireless channel is the channel which actually electromagnetic wave pass back and forth. Just like when you talk between each other, audio waves goes between people. Electromagnetics waves will pass through people. You can see that a cell phone talking to cell phone tower. Okay, then since it is electromagnetic, various kinds of polarizations are possible. Linear, when the electric field will be in a particular plane, it will be jumping back and forth in a particular plane. If it is circular, two planes will be there, electric field will be jumping back and forth. As a result, the resultant electric field will be moving in a circle. It's called circularly polarized wave. And similarly, can be elliptical polarized wave. And what is the message? So in order to predict the performance of wireless channel, you must solve Maxwell's equation. It is not an easy job, right? The boundary conditions are obstruction caused by ground, buildings, vehicles, and you basically have to solve this partial differential equation devised by or pioneered by this Maxwell, James Clerk Maxwell, way back, long back. And to solve this in a situation like, whenever we have passed BTech and so on, we learn with mathematics, learn some mathematics, we solve partial differential equation. These Maxwell's equations are nothing but Maxwell partial differential equation. In order to solve what are the signal imperfections in the wireless channel, you basically have to solve the partial differential equation. Every partial differential equation has a boundary condition. And what kind of boundary conditions we are trying to solve, which is a challenging problem. That is why this problem is like an elephant walking on a rope. It is nearly impossible. Okay. So that is something which I want to tell you. These boundary conditions are really, really challenging. So you cannot exactly solve the nature of propagation of electromagnetic wave. So wireless channel will always have some uncertainty. Okay. In order to describe this different kinds of polarization, it is very easy. Sometimes people spend a lot of time to understand what is polarization. there are three components in electric field, Ex, Ey. Suppose a wave is moving in Z direction, there will not be an electric field, plane wave. But if there can be an electric field in the Y direction, or if it is a circularly polarized wave, the direction of propagation is along Z. There can be two components at the same time, simultaneously, 90 degree with 90-degree phase difference. So as a result, the electric field will move in a circular manner as the wave propagates forward. So now you can imagine the complexities involved. You have electromagnetic waves on one hand, which is dictated by physics, physical laws. Then you have a technology which need to overcome all sort of problems of sending and receiving electromagnetic waves. So without knowledge of electromagnetic waves, you will not be able to use this technology properly. That is my message. Okay, that's the bottom line. So why this wireless channel is very intimidating? Because you see, when an antenna radiates, for example, here is a horn antenna which is radiating, right? It is intended to radiate in the forward direction, okay? But unfortunately, there will be side lobes. You have all learned, and side lobes are a nuisance because when you have side lobes, a little radiation is there in the other sides also. The side lobes will cause a lot of trouble. It will reflect from the ground, okay? And there will be, along with the direct path, there will be reflected path. As a result, constructive and destructive interference can happen. And there will be fading, a process called fading. And wireless channel, you will not be able to receive any data in the other end. So IoT technology will miserably fail. So you must know how to use wireless IoTs properly. In order to do that, you must know fundamentals of antennas and so on, okay? And this is not very difficult because through good mathematical models, once you study antenna technology and so on, life becomes very easy. And you can be very good system engineers in IoT. For example, you see the electric field radiated by an antenna. Amplitude will change as it moves forward, inversely proportional to distance. So amplitude will be inversely proportional to distance, and there will be a phase shift of the cosine, you see, as a function of R by C. I'm not going to deeper into this. And suppose you have two antennas, the link you can predict the link very nicely through Friis transmission equation. ECE BTech will easily understand what is Friis transmission equation. The power received will keep on diminishing or reducing as the receiving antenna moves far away from the transmitting antenna and so on. So this is called the path loss curve. And this is the theoretical, the solid line is theoretical, and this is the measured. So the path loss curve predicted when two antennas directly talk to each other really work. It's a good model for the link prediction between two antennas when it is in the free space. Okay? Good. This is the formal definition of what are the advantage of wireless channel. I've already talked. I'm not going deeper into this. Okay? Now, I'm going to talk to you about wireless channel impairments in IoT application. Now, the first thing is there will be free space and a moving antenna. Transmitting antenna is stationary, and there is a free space surrounding the transmitting antenna, and then there is a moving antenna. What are the applications? For example, satellite communication is one of the best examples. Satellite trying to communicate to a ship or a plane. The plane is moving. So this is a typical example. Similarly, drone. Drone is sensing the moisture by the sensors are deployed throughout the farm, and drone is receiving signals. There is free space in between the drone and the ground. However, drone is moving. Now, what are the signal impairment when it is a moving antenna? There will be a phenomenon called Doppler shift. Okay, Doppler shift. You can easily prove this. Why the Doppler shift happens? Okay, I think it is very trivial. So you must know about the Doppler shift. And Doppler shift is not good. Why? Because when there is a shift in carrier frequency, depending upon the speed of the object, the carrier will be. You have to make sure that the receiver should be able to deal with the situation. It must have a wider bandwidth. Otherwise, wireless IoT will miserably fail. So in order for wireless IoT to work, you need to deal with the Doppler shift, right? So this is one signal impairment. So now there is a reflecting mode and a fixed transmitting and receiving antennas. What is it? Command and control of a robot is a typical example. Okay, the robot is just, you can make the robot move in any direction by some command and control. Then what is happening when you are trying to send the signal from the transmitter to the robot? What will happen? Unfortunately, there will be a reflection from the wall as well. So the receiving antenna in the robot will receive a direct line, a direct signal, as well as an indirect signal after reflection from the wall. You can see this. You can assume this wheeled thing is the robot. Now what will happen? You have two different wireless channels unknowingly. One is from the reflection of the, now they can constructively or destructively interfere. As a result, signal can be lost. Now you can imagine, without solving such scenarios, how will we make wireless IoT work? So you must know how to solve this kind of issues. And this sort of problem is called delay spread. This will lead to delay spread. There will be signals, two different signals, one coming with a delay. So this whenever you hear delay spread, you must understand there will be two or more different paths coming at the receiving antenna, and that will cause some constructive or destructive interference between each other. It will cause fading. Signals won't be received, and the technology will be unsuccessful if signals are not received properly. We must solve this. Now there is multipath fading. When a drone, for example, move in a city, there will be lot of reflections from building and so on and so on and so on. So there will be something called multipath. There will be not just one path or two paths, there will be hundreds of paths, right? So as a result, what happened? There will be, signal will be increasing and decreasing. So you need to deal with such large dynamic ranges in your communication system in order to make this, for this wireless IoT be successful in such scenarios. So here is a crowded traffic where IoTs are destroyed. You will experience this kind of situations. So your system has to be very robust in order for IoT to be successful. So this is called multipath fading. Now you see an empirical model to include ground reflection. Okay, you can predict basically what is the effect of ground reflection if there is based on two-path model. These are all trivial stuff. If you know this kind of pathless model, you will make your antenna designs properly so that it will deal with such situations very nicely. So little bit of antenna knowledge will solve many issues. For example, the application which I am presenting is a robot, a competition between robots in playing football. Okay, and the transmitter, it will be manually controlled. These robots will be manually controlled by the competitors, two different teams, right? Now you can imagine when the transmitting antenna transmits some command and control to the robot, there will be a direct path and an indirect path. So the indirect path will cause the system to fail miserably. You see, suppose there will be destructive interference, there will be nothing received here. So there will be problem. So you need to make sure that your system is very robust. So you must have some knowledge on antennas and so on, so that the IoT applications, such kind of IoT applications are successful. Now you can imagine large cities where IoTs are deployed. The right side picture, you can have a look. You see the radio link. There are the red spots are places where are good signal coverage. There are places where there are very weak signals, and the blue areas have shadows, radio shadows. So you should imagine when IoTs are deployed, IoT technology is deployed. For example, smart city. Such kind of situations need to be solved. It is easy to design IoT devices, standards, and so on, but the IoTs will be successful only when the wireless channel impairments are dealt properly. So it's really, really important for you to know radio wave propagation, polarization, and so on, so that the IoT technology is really successful. Now, how people deal with such situations? For example, frequencies up to 1.5 gigahertz, where cell phones, technology is very successful. A considerable amount of investment is gone into by European Union and US research entities, okay, through universities and so on, to measure such kind of scenarios, channel. So they have created empirical models of channel in cities and so on. And similarly, for IoTs to be successful, you need to, the situation is completely different. The IoT things, Internet of Things, the things are really located in hostile places. As a result, the link will be, there are a lot of research need to be done before you really be successful in IoT technology, wireless IoT technologies. And also the frequencies. Cell phone was operating up to 1.5 gigahertz, but that's not enough. In future, for example, Wi-Fi based IoT, it has to deal with 5.4 gigahertz. And the thing, the Internet of Things, that thing may be located in a harsh, wet place, maybe a sensor in an agricultural field. So do you know what is the channel, how the antennas exchange information, whether the link will be good or not? It's uncertain. So there is scope for a lot of research in this wireless channel modeling and so on, as far as IoTs are concerned. And now there are statistical channel models, to make things complete. I just wanted to make sure that how you can make simulations of IoTs, for example, in MATLAB or any library, mathematical libraries and so on. You can use statistical channel models. Statistical channel models work like this, okay? It is like a linear filter. The channel is assumed like a filter. And X here is the signal which you are passing through a channel. And Y is the output. So if you can define, all of you have studied filter works like that. In the digital filter works like that. It's a filter, okay? Convolution between an input and a filter. Now here filter can be assumed like the channel, which cause imperfections. Somehow you identify the filter taps. What is H? You will be knowing more about the channel. This is the idea behind statistical channel models. People have come up with good models of this H so that you can predict what is the output, right? And you can also deal with the noise. For example, the block diagram deals with it. It's an L-tap, LTI, linear time invariant channel. I'm not going into the details because it's an area in itself, but for the sake of completeness, I'm presenting here. Now, coming to statistical channel models, you have the Rayleigh fading channel, you have Rayleigh fading channel. What is a Rayleigh fading channel? These are all time-tested channel models which can work in certain situations. In Rayleigh fading channel, there will be a direct path and lot of indirect path. Okay, you can see that a car is in between buildings and a tower, cell phone tower, or a IoT gateway. It need not be a cell phone tower, it can be an IoT gateway. So the car is here. You see there is a direct path, the green line, and lot of indirect path, which are reflections on the building. There can be reflections from the ground also. So now you can imagine the signal you receive, there will be having a destructive or a constructive interference. And it's very unpredictable. You cannot predict it. So people have come up with a statistical model called based on Rayleigh distribution. You design these filter paths according to Rayleigh distribution, and we can make beautiful simulations in an urban scenario with Rayleigh fading channel. You also have the option of Rayleigh fading channel in your simulations. Rayleigh fading channels means what? The IoT gateway is obscured from the moving vehicle. You see, there is no direct link between the car and the IoT gateway. In such case, you can use Rayleigh fading channel. So you can gather a lot of information about how to make an IoT simulation possible. Because simulation will lead to a lot of insight into the actual performance of IoT systems. So before you just blindly deploy an IoT devices here and there to make a system, if you make a simulation with certain models, fundamentals of electromagnetic waves and so on, you will gain a lot in performance, okay, when the system is actually deployed. You can optimize the cost, number of nodes can be reduced, radio links are better. So you have to study these concepts. Then only IoT technology will be really successful. Now, challenging IoT use cases. So, now it is very easy to say, oh, IoT is solving everything. But you see, left side, you are seeing a big factory floor. You can see thousands of equipments, people moving, very harsh electromagnetic environment. Harsh in the sense there are a lot of metals. They are all sources of reflections. And imagine when one poor little thing will communicate with another poor little thing in another corner of this factory floor. Where is the radio link? There will be a lot of reflections. So it is easier said than done. Okay, IoT, you need to deal with such situations. Then coming to my pet IoT application, my favorite IoT application, I want to use IoT technology for successful smart farming. I need to deal with moisture. The sensors will be located close to the ground, very harsh environment. Poor little sensors, how it will communicate with the gateway which is located in one far end of the field. So for these applications to be successful, you need to deal with wireless channel. So dealing with wireless channels is most challenging. So what my message is, do more great work. Do more great work so that IoT can be used successfully in India and elsewhere. So we need to deal with wireless channel. And thank you for listening. And I would like to deal with few questions.
Hello, sir. There are a few questions.
Yes, please, sir.
Okay, so Ajay is asking two questions actually. So he's asking about, first one is about the security vulnerabilities of IoT.
Yes.
And the next one is how we can integrate IoT for a sustainable future.
Yes. Yes. So these are very active research topics, really active research topics. Okay. For example, you know how vulnerable we are even today with our internet today. People can hack, right? Your computer is very vulnerable. Now imagine a situation, lot of things which are connected with internet are located here and there doing critical jobs like smart city. You know, suppose our enemies gain knowledge of these systems. For example, Pakistan or China. Sorry, I should not name countries. Okay, because from their behavior we can say that they are hostile to our country. Suppose they hack our smart city network. You can imagine the situation. You see, there will be no power, there will be no water, people will be hungry. So it is very, very important. This security of IoT technology is a very, very important topic. It's a very relevant topic. And there are two layers of security. One is the security which is already kind of good research has happened. For example, the gateway to the cloud. Okay, a lot of good research has happened. But between things to gateway, not much research is done. This is happening, right? It's very happening research. And it is a really good topic for PhDs and masters and so on. So I am sure that that is a very, very, very important and very relevant question, and it has to be solved before this technology will be successful. Okay. Now the second question, can you repeat the second question once again?
Yes, sir. He was asking about IoT for sustainable future.
Sustainable future. Yes, of course. See, I have already told you about for example, you see, we are consuming a lot of resources more than what is required, right? Today, you know, for example, I am sure when we all wear smart gadgets in our body, we will consume and we are not aware of the problems. Okay, we will naturally be aware of the problem. Today, we are eating a lot of junk food, fat, and so on because we are not aware of what is the implication of our eating habits, right? And suppose there are sensors in the body which gives us warning, then naturally people will be very concerned about too much food intake. Okay, so people will be healthy. Okay, that is one thing. It is a indirectly a very good thing because You will not consume you will not buy a lot of groceries, you will not buy a lot of things and more than what is required. Today, most of the problems related to health are from our eating habits. So eating habits are controlled naturally through our body area network and sensors, wearables, and so on. Suppose people are becoming very conscious, will be very conscious about these things, it will indirectly have some implication. Similarly, now consider the agriculture. Okay, today we are using a lot of fertilizer more than what is required. Our farmers are non-knowledgeable about the fertilizers consumption. And due to this fertilizing we are actually destroying the nutrition of the plant. Okay, and also we are creating a bad situation because we are destroying the soil quality of the soil in the long run. So if we deploy smart sensors in the agriculture, okay, we will consume less resources like fertilizers. Similarly, less water. For example, today, if you give a hose pipe to a gardener, he will just use this hose pipe in the same force to even a rose plant or a big tree. He is not aware of the. So when you make things smarter, for example, the smart sprinkler system, there is a small camera attached to the smart sprinkler system. Whatever you are watering, for example, you know what you are watering. Okay, just like humans, we know what you are watering. If things are connected with smart sensors and actuators, we will know what you are doing. And once it is made automatic, this process become automatic, you use less water naturally. It leads to a sustainable future, right? So the resources will be, and similarly in smart cities, you see, today we are consuming, lot of electricity is being wasted today, isn't it? Unnecessarily, there will be breakages, outages, the breakages of cables and so on and so on. If you deploy smart sensors in the network, okay, the grid will be very efficient. People are predicting that 50% to 60% you can save the energy consumption in a city by making the grid smart. Okay, similarly, when the smart grid will be deployed, you will generate electricity in your own houses through solar panels, and you will be giving it back to the grid. What a beautiful thing. You are giving it back to the grid, to the people in requirement. Because you will be, bigger the house, more solar panels, more electricity will be generated. You don't need a large amount of electricity. You can give back. And as you know, solar technology is a sustainable energy technology, right? You're not taking anything from the ground or anywhere. The sun is shining, so you're just tapping that and you're giving it back. What a nice future we will have if you have the smart grid where individual households will be generating a little bit of electricity and giving it back to the grid. So I see the IoT deployments will lead to very sustainable future. Yes, I hope it answers the query.
Sure, sir. So shall we move to the next question?
Yes, sir. Yes, please.
Okay, so the next one is from Bhavesh. So he's asking in the area of agriculture. He's asking many sensors cover only in localized position. If the field is huge in size of acres, we won't be efficiently able to cover the place. Is there any way to overcome this?
Yes. See, radio waves, when it is wireless, there is a little issue here. The sensors, very good question. The sensors are naturally located close to the ground, monitoring things. And if the antennas from you need antennas to communicate to the gateway, right? If the antennas are popping a little bit higher above the ground, what will happen? You have cables to connect the sensor to the antenna. So you would like to have the antenna close to the sensor itself, right? So that means you have an antenna which is located very close to the ground. So you can imagine the situation when an antenna is very close to the ground and dense vegetation, lot of moisture around. Okay, so it's a very, very challenging scenario. Okay, now certain things can help us For example, the mesh technology, the mesh network. I have told you about the wireless sensor network area. These kind of networks are very popular, right? The one particular node will not directly talk to the gateway. Okay, the one sensor can talk to the nearby sensor and nearby sensor and nearby sensor, and finally, one particular sensor can talk to the hub. For example, consider the tree network and mesh network and so on. You can choose what kind of wireless sensor network you will deploy. So that is why a lot of knowledge is required for the node-to-node communication. What kind of decision you will take? What kind of the connectivity configuration you will use? So it all depends on the kind of application. And the application which you are told in agriculture is very, very challenging. So you need to choose a particular connectivity configuration according to the requirement, right? So that is the only way. And another important thing you must understand, there is a lot of scope for good research in channel modeling of agriculture, because it is naturally a very challenging channel condition. It is highly commercial. What we do, what kind of research we do depends on commercial benefits, right? So far, a lot of investments have gone to cell phone, Bluetooth, and so on. The channel models were all empirically identified. At least people can use some kind of channel models. But when it comes to agriculture, for example, the last slide. Yes. This agriculture, for example, channel modeling is not done. And channel modeling depends on the type of agricultural field, type of vegetation, type of plants, crops you have in the field. So this is where a knowledge of electromagnetics, antennas, and all are very critical in successful IoT in agriculture. Hope it answers my question.
Okay, sir.
Yes.
So the next question is from Deepak. So he's asking about frequency bands for the frequency bands that he should consider for modeling, channel modeling for IoT. He's asking if we can use the same bands used by Wi-Fi, body area network, etc. For the same IoT modeling.
Yes, very good question. What frequency bands I should choose? Okay, the lower the frequency, naturally larger the range. That is a thumb rule, right? That is why UHF is quite interesting. LoRa is very successful because they use UHF frequencies. Now, when it comes to ISM band 2.45, Wi-Fi and so on will work in ISM band 5.4, 2.45. Now, the problem I have told, the plus and minus of both. Suppose you have large data to be exchanged between things in IoT, okay? Then naturally you cannot consider LoRa. Okay, LoRa has limited bandwidth, very limited bandwidth, and 6 kbps is the maximum data rate. And if you cannot send, for example, a camera, a drone is taking a picture of a field, okay, and the drone is the thing, and you have to pass this data to the internet in real time. LoRa technology is not good because it has only 6 kbps. You take years to send the data. Whereas on the other hand, you have a moisture sensor located on the ground. You have very little data, hardly maybe 32 bits of data, right? Moisture, the variation in moisture in a soil is very small. So you can represent the moisture content with few bits. So you can send say this 32 bits over the air. 6 kbps is more than enough. And it can reach a remote place with the LoRa technology very easily. So it all depends in the engineering skills and decision making, right? And the kind of application you are using. So that goes a lot, what kind of data you are dealing with, okay? And how fast you need to communicate. Sometimes you see, if you have enough time with you, using LoRa for sending a picture is not a bad idea, because you can send this maybe a 5 MB file over a longer time through LoRa, it's 6 kbps, or a shorter time with with Bluetooth technology, which has a 1.37 Mbps throughput. But Bluetooth has BLE, for example, it has a maximum throughput of 1.37. So that will be sending faster. But if your decision making is not that critical, you can take some time. For example, sending some non-critical image through to a far distance, you can consider low. So it all depends on the application, how critical your data is, and so on. The bottom line is there are different protocols, Wi-Fi, cell phone, each have different data rate, range, and so on. And you must choose a technology or a protocol or an IoT protocol according to your requirements. Right? Yes, I hope.
Next question is from Danesh Raj. So he's asking, which is the best model to measure propagation model, empirical or statistical model, and how to choose the best one?
Yes. See, empirical model, these are based on pure physics, right? Means you should have a knowledge about the radio wave propagation. Because, for example, when you have two antennas, right? You don't need to do a simulation, right? You can just make a quick assumption or a quick model. Okay, ground is located this distance, certain distance from the antenna, and the receiving antenna is located at this distance. The antenna gain is very good. When the antenna gain is very good, there will be a good line of sight between the antennas, right? So this statistical model, on the other hand, is more useful for non-line of sight applications. For example, within the city, large areas, and so on, where you have no idea about the radio wave. If you think about it, you know, it is like that elephant walking on the rope. You cannot solve this. You cannot imagine it. Can we imagine how the radio waves come to your mobile phone, living in an urban place, surrounded by a lot of flats and so on, tall buildings and so on? The way it comes, when you think about it, it is very, very, we cannot imagine it. It's an unimaginable thing for a human being, how it comes. It might have hit several buildings between the cell phone tower and your phone before it reaches your phone, delivering your internet, your WhatsApp, and so on. So there you cannot apply an empirical model. There is no empirical model, by the way. Whereas empirical model exists when it is short-range communications, when you know there is some kind of line of sight. And today the empirical models, by the way, are being developed even with walls also in between. With your, more and more electromagnetic engineers are coming to this field, actually, basically with their knowledge, they are trying to solve how to make good models. For example, within a building, there will be 10 walls. It's an electromagnetic problem, and it is a tractable electromagnetic problem. You can draw your walls in a particular simulator, you can make an empirical model, and so on. So it's a good research area, by the way, for a PhD, making empirical models within the building. And you can prove your empirical model also by means of experiments. Okay, you can have an antenna in one place, another antenna in one place. You can, whatever you have simulated and made with curve fitting or pole zero models and so on, you can compare it. I would like to, few PhDs coming out of these areas and so on. So empirical models are, but the bottom line is empirical models are can be used for tractable electromagnetic environment, like between the rooms, between two people within the room, indoor robot propagation. So these kind of problems are we can apply empirical models. But when it is a large area, LoRa, for example, 15 kilometer to 100 kilometer, the same situation we will face as in cell phone, where there are a lot of obstacles and so on between two antennas. So empirical models cannot be applied, and it is intractable as far as empirical models or electromagnetic simulations are concerned. There you resort to statistical models, where, which I told, it is like you imagine the channel as like a filter, your input as the input to the filter, and you do a convolution and you get an output. And the research will be put into identifying the proper taps of the filter. there is an H. If you go back to one of the slides, if you recall, there's the H. You identify that H, and people put effort into identifying that H. Okay, you can use this 5-tap model in a certain situation. It will work. And you can use that 5-tap model which somebody published in your simulations and prove that, oh, this is the bit error rate you are achieving, this is the throughput you are achieving. So this is called the simulations based on statistical models. But empirical models are more close to physics, and I would say that empirical models are really, you must know empirical models because most of the IoT applications are short range, right? So long range, and you can have interoperability also. In some situations, you can have a mixture of IoT technologies. For example, IoT, a short range IoT technology. Then when it is communicating to longer ranges, you can use the LoRa. So such kind of deployments are also in pipeline. People are working on it. Yes.
Okay, so next question is from Pranav. So he's asking, what is the solution for delay spread?
Delay spread, yes. This is where if you recall, the delay spread is because to reflections, more and more reflections coming in the receiving antenna from different directions. That is why you will see, instead of one signal, you will have multiple signals. One maybe a stronger one and many weaker ones, right? Now, the question is how to make the direct one very stronger. Then the weaker one will be, that will not have any effect, right? The reflected ones. So that is where antenna knowledge comes into picture. So for example, if you are directing your electromagnetic wave to a place which is where there is no receiver, there is, you are not able establishing a direct link properly. So you must know what kind of antennas you choose, okay? What must be the radiation pattern of that? And this way you can make the delay spread smaller. The other way is, today, for example, in communications, there is a real time in certain protocols, there is a real time channel measurements. For example, as you know, in cell phone technology, GSM, 3G, 4G and all that, this is a very happening thing. Out of a chunk of bits, more than half is the control bits. If you have gone through the protocols of GSM. And what are these control bits? The control bits, inside the control bits, a major chunk is actually measuring the real-time channel, identifying the real-time channel. How do you identify the real-time channel? You send a known signal from the transmitter to the receiver. And you will not receive the one which you are intended to receive. And from that, okay, then so it's how you can simplify the explanation. Suppose you know your input, okay, and you don't know what is the channel. So the impulse response of the channel come in between. The input comes in the input input port, and you know what is supposed to be the output, and you are measuring in real time the output. So if you know the output and input, you can immediately build up the channel on a real-time basis, and then you can cancel it out. This is the idea behind the GSM protocol, starting from cell phone. GSM, it has been actively deployed. That is a real-time channel measurement using control signals. This control signals means known signals which are known to the transmitter and receiver is used for a certain duration, and you measure what is being received, and you build up that HT, the impulse response, and you do an inverse operation. If you know what is HT, you do a 1 by HT, and the channel will get cancelled. The imperfections in the channel get cancelled, right? So this is a way to solve this. But you see, what is the price you are paying? Out of certain number of bits you are passing from one point to other, a lot of bits is dedicated, or a lot of signaling is dedicated for channel measurement. And based on the channel measurement, you're canceling out the channel and you are receiving a beautiful signal in the receiver. But what's the price you pay? You make more signaling between transmitter and receiver. You have more communication between the transmitter and receiver. As a result, what will happen? Your power consumption will be more, your latency of the system will becomes issue, and so on. So it's not a good idea to have large signaling for just measuring the channel, right? So these are, but however, good technologies for solving these things, these channel imperfections. Yes. Does it answer my question?
Yes, sir.
Yeah.
So the next question is from Lavanya. She's asking about Internet of Underwater Things, and also asking if you could give the difference between IoT and IoUT, and then the best channel for IoUT.
Yes. As you know, underwater means it is a very hostile place for radio waves, electromagnetic waves, right? So if you jump into a pool with your mobile phone, you can hardly communicate to the outside world. We know that because water is will highly attenuate the radio waves. So underwater is a very naturally challenging place. So none of the protocols deals with the, which I showed deals with the situation. I guess that this is a very good area, and but I'm sure it is not the top 10 IoT application. So maybe in military, navy, and so on, you have you can and of course there are maybe you want to monitor the health of oceans, or you want to deploy sensors and so on within oceans. So we need to understand, because all the problems of electromagnetic wave propagation inside the water will come into IoT deployment underwater. IIUT. I'm hearing that first time, this term. IoT UT under IUW. Okay. So, but we would be able to solve this. I think the learning which we have gained in several other areas, after all, IoT means, the thing will have internet and the channel will be already existing, and people who have dealt with such situation in other communication system, we can gain that and deploy IoT in underwater. Yes.
So these are the questions, sir.
Okay. Thank you.
Thank you so much, sir, for a wonderful session. I hope the participants must have got enough knowledge from your presentations.
Thank you, sir.
Thank you so much, sir.
Yes.
And participants, please leave your feedback. The link is given in the chat box. Sir, shall I end this session?
Yes, sir. Yes, sir. Please. Thank you. Thank you for Sethu sir and for the opportunity. And Sai Shibu, Shivaya, thank you.
Thank you so much, sir.
Thank you.